Hello everyone, how are you all doing? I hope you all are doing good. In today's video, we are going to start a new chapter, that is work and energy. So let us start with what is work. Now, any mental or physical activity you do is referred to as work. And for performing any activity, we need energy in our body. Correct? So, whatever energy is required to apply a force on any object, which will cause displacement of that particular object. Correct? So work will be said to be done when a force applied on an object will cause displacement of that particular object. Correct? So we can say that work is equal to force into displacement. Now, so work is equal to force into displacement. Now what do we understand by displacement of an object? Now suppose a child pulls a toy cart, right? So force is applied along the direction of the string, right? And while the cart is pulled along the horizontal surface, as you can see in the picture. Now in this case, in order to calculate the amount of work done, we have to convert the applied force into the force acting along the object along the direction of displacement. Followed? So now let F be the applied force and F1 be its component in the direction of displacement. See. So this is the force and this is the component which is acting in the direction of displacement. And let S be the displacement. Suppose from here to here it is pulled, so that S will become the displacement. And the amount of work done is given by work done is equal to force, that is its component which is in the direction of displacement, into displacement. So work is equal to force into displacement. That becomes our first equation, right? Now the force F is applied in the direction of the string, that is at an angle with the horizontal. See, the force F is applied here in the direction of string, but the displacement is here, correct? F1. So it forms an angle and that angle is made with the horizontal. So we can determine the component F1 of this force F, which acts in the horizontal direction by means of trigonometry. Followed? Now force used for the displacement. Now cos theta, this angle we are trying to find out, base upon hypotenuse. So base is F1 and hypotenuse is F. So this will give you F1 is equal to F cos theta just by changing the sides. Thus the work done by F1 is W is equal to F cos theta into S. Followed? And then if you see, work done is equal to force into displacement, right? So force into S cos theta. Followed? So unit of work. Work is equal to force into displacement, correct? Force into displacement. So in SI system, the unit of force is Newton and the unit of displacement is meter. Followed? Unit of force is Newton. So force becomes Newton and displacement is meter. So thus the unit of force is Newton meter. And Newton meter is called as joule. So what will 1 joule be? If force of 1 Newton displaces an object through 1 meter in the direction of the force, okay, it should be in the direction of the force. The amount of work done on the object is 1 joule. Therefore 1 joule is equal to 1 Newton into 1 meter. Followed? In CGS system, the unit of force is dyne and that of displacement is centimeter. Followed? See, in SI system it was Newton and meter, whereas in CGS system it is dyne and centimeter. So the unit of work done will be dyne centimeter, and this is called as an erg. Okay, there it was called as joule. Followed? So 1 erg is if a force of 1 dyne displaces an object through 1 centimeter in the direction of force. This is very important. In the direction of force, the amount of work done is 1 erg. Okay. Both these slides are very important, students. You should know the definition of 1 joule, 1 erg, their units. Okay. Exactly, you have to remember what is 1 erg, what is 1 joule, what is the unit of force in CGS system and in SI system. Followed? So relationship between joule and erg. Now we know that 1 Newton is equal to 10 raised to the power 5 dyne and 1 meter is equal to 10 raised to the power 2 centimeter. Now work is equal to force into displacement. So 1 joule will be 1 Newton into 1 meter. Correct? So now you putting the values of Newton and 1 meter, you will get 7 raised to the power 10 raised to the power 7 dyne centimeter. Follow? So 1 joule will be 10 raised to the power 7 erg. This also you should know. What is the relationship between joule and erg? I hope it is clear to you. What we have done is, in the formula we have put the value for Newton and meter. Okay, this one. And we get this. Followed? Now students, we are going to talk about this particular angle, okay, that is theta, right? So positive, negative and zero work. Now when the force and displacement are in the same direction, see, same direction, so theta will be 0, okay, and that is why the work which is done will be positive work done, right? Now when the force and displacement are in opposite direction, means you are applying force in one direction and the displacement is happening in another direction, so theta will be equal to 180 degree. In that case, the work which is done by the force is negative. Followed? Now, you are applying the force but it does not cause any displacement. Or when the force and the displacement are perpendicular to each other, that is theta is equal to 90 degree, the work done by the force is called as zero work done. Followed? Now suppose an artificial satellite is moving around the earth in a circular orbit. As the gravitational force acting on the satellite and its displacement are perpendicular to each other, the work which is done by the gravitational force is 0. Why it is 0? Because the gravitational force which is acting on the satellite and the displacement which is happening along the tangent to the circle, right, they are perpendicular to each other, and because they are perpendicular to each other, the work done by force is said to be 0. Followed? Now let us take few examples here. The first example, calculate the work done to take an object of mass 20 kg to a height of 10 meter. Correct? Now gravitational pull is given. Gravitational pull means the force by which earth will pull any object towards itself. Okay, so gravitational pull is 9.8 meter per second square. So what is given? Mass is given, that is 20 kg, and see, height is 10 meter, so displacement is 10 meter, and the gravitational pull is 9.8 meter per second. So force is equal to m into g, right? So this will give you 20 into minus 9.8. Now why we are putting a negative sign? Because the displacement is in the opposite direction. See, gravitational pull will be from the earth side, so the force is applied downwards, but where we are taking the object to a height, means it is going in the opposite direction, so it will be minus 9.8. Followed? So force is equal to minus 196 into n, right? See, we know this, that force is equal to mass into acceleration. So this force is given by negative sign. Followed? So work is equal to force into displacement. Now we know the force and displacement is 10 meter, of course. So this will give you minus 1960 joules. Why we are taking negative sign? It appears because the direction of force is opposite to the direction of displacement, so that the work which is done is negative. Followed, students? Very simple formula we have put here. Now second example. Praveen has applied a force of 100 Newton. 100 Newton. Okay. At an angle of 60 degree to the horizontal. So it becomes cos 60 degree. Followed? Now value of cos 60 degree is half. 1/2. The object gets displaced in the horizontal direction and 400 joule work is done. So how much of work is done? It is given. What we have to find out is displacement. So theta is equal to 60 degree. Force is equal to 100 Newton because that is given. Work done is equal to 400 joules. What we have to find out? S, that is displacement. Now for work done, we know that W is equal to force into displacement cos theta, right? So putting the values, you will get 4 into 2 is equal to S, that is displacement. So how much the object is displaced? The object is displaced through 8 meter. I hope both the examples are clear to every one of you, right? In the next video, we will start with the new topics of this chapter. Thank you so much, students, for watching the video.